Alright guys. Now guys, what I defined the other day was a domain, okay? Sorry. A domain is the amount of x values, okay, in a function. And what happens is they give you what's called the range. What is the answer for f of x, okay? So you have domain and range, okay? Now range is all the values that the domain will produce, okay? So for example, in this question here, if I said x 3 less than or equal to x less than or equal to 5, technically speaking, the domain is 3, 4, and 5, provided I say x element n. If I said x element r, is there a limit on how many numbers I can come up with? No, I could do 3.1, 3.11, 3.12. I could just keep putting more and more numbers on it every time. So the x element n part is very important because it tells me that I'm only allowed to use whole numbers. Alright, so that gives me 3 numbers here. Okay, and then these numbers will map onto the range. And the range is basically the answer they produce. So for example, the first one's going to be the square root of 3 squared minus 9. And we all know that's square root of 0, which is 0. The next one could be the square root of 4 squared minus 9. 4 squared minus 9 is 16 minus 9, which would be the square root of 7. And then finally 5 squared minus 9 is going to be 25 minus 9, which is 16, which is 4. Okay, this is a range. The range is paired off with the domain. Now, outside the range is something that's called the codomain. The codomain is bigger than the range, has a much bigger value, and it's all the possible values that could happen. But because we limited it by saying x, the domain can only be in between 3 and 5, this means the range is a small amount of values. The domain is all the values, the codomain is all the values that we could have. Okay? Now, the problem here is with the range is, imagine I didn't limit it. Now, what numbers are not possible in a square root sign? Any minus numbers whatsoever. Okay? So what we got to figure out is, for what values is x squared minus 9 smaller than 0? It's an inequality equation. We factorize and we get x plus 3, x minus 3 less than 0. Okay? And what we used to do is identify this curve, U-shaped or N-shaped? U-shaped, okay? So what we usually do is we'd usually pretend that's an equal to 0, and we'd say, okay, it's x minus 3, x equals plus 3. We draw a rough sketch of our graph where it hits 3 and minus 3. This is relating back to chapter 1 and 2, where we did this regularly. Okay? So minus 3 to 3. You then go, where's the function below 0? It's above 0, it's above 0, it's above 0, and now all of a sudden it's below 0. Now see these values here, the values of minus 3 to 3. We're not allowed to have these values, because if we use any value between minus 3 and 3, it will produce a negative number which we can't get the square root of. So this means that we're only allowed to use values that are smaller than minus 3 and bigger than 3. Let me give you an example. Pick the easiest number between minus 3 and plus 3. 0. 0 is the easiest number to test out. If we go back to the equation at the very beginning, alright, and what we can say is, what happens if x is 0? If x is 0, what happens? It becomes the square root of minus 9, which is impossible. This trend will be seen for any number between minus 3 and 3. Pick a number outside the region. For example, pick the number minus 4. Will minus 4 produce a positive number? Minus 4 squared is what? 16 minus 9? 7. Positive number. Pick a number bigger than 3. 4 again. Once again, 16 minus 9, root 7. So that's how we answer that question. It's a unique question in this chapter, but nonetheless a very valid question. Alright guys, moving on here. What we're going to have next is question 24. Okay, so question 24. To graph the quadratic function g of x equals ax squared plus bx minus c, where x element r. This means x is any value. Fraction, negative number, decimal, doesn't matter. That's why it's a consistent line. Okay, so every x has a y value, so that's why it's a continuous line. Okay, element R. Now, write down the values of p. Now p, okay, what I need to figure out before I figure out p is I have to figure out what is my a and b value. Is there any 2 points that have both numbers in them? Like minus 1 and 4, 4 and 9. Remember, the y value is the g of x value. So 4 equals a times minus 1 squared plus b times minus 1 minus 3. 4 equals a minus b. I'm going to bring that 3 over to the other side. It goes 4 plus 3. A minus b equals 7. Okay? A minus b equals 7. Now, the next equation, that's a simultaneous equation. Yeah. Work with, yes, one second. Yeah, go. So, some people are asking me, why would I do this method, okay? What I know is for any function, okay, so if I had a calculator and I wrote down any quadratic function like x squared, just do it like this, right? So let's say x squared minus 3x, for example, okay? And I said this is a graph between minus 3 and 6, right? And it's steps of 1. When I draw this graph out, it represents a U-shaped function.
They're all in the line.
So all these points represent the function. So for example, it was x squared minus 3x, correct? Yeah. Right. Now what happens is all of these functions represent any point. So if I pick any point here, let's say 2 and minus 2. Yeah? So 2 and minus 2, for example. 2 and minus 2. 2 is the x value, y is minus 2. So I say minus 2 has to be equal to 2 squared minus 3 times 2. And what you'll find is any point on the line will balance itself out when put back into the original equation. Okay? That's got to happen if the points are on the line. Okay? So when I look at this equation, I go, this isn't the normal type of equation. This equation has letters. Okay? Now the problem with letters is that I have to figure out what these letters are. Now, if I were to use 0p and put it directly into the function, I'm now introducing another letter. And I don't even know what a and b is yet. So what I do when I see letters in this type of equation, I look for 2 points which have no letters in them, just numbers, numerical data, this one and this one. And then because these are points on the line, I know they must balance the equation, and therefore I can find out what a and b is. Okay? So what I say next is g of x equals, g of x is 9, and 9 is going to be equal to a times 4 squared plus b times 4 minus 3. Bring the minus 3 over here, so we're going to get 12 equals 16a plus 4b. Recognise that they're all multiples of 4, so I'm going to get 3 equals 4a plus b. Lucky for me, when I add them both down together, they are going to cancel. I'm going to get 5a equals 10. A therefore equals 2. If a is 2, 2 minus b equals 7. That must mean that b is going to be minus 5. So a is 2 and b is minus 5. I'd go back to the very top upon this data, 2 and then minus 5. Just change it immediately in the original question, and then I'm going to start on the next part. P is a 0p is an equation, okay? And this equation here is 0p is an equation that satisfies is a point that satisfies this equation. P is the y value and 0 is the x value. So we're going to get is P is g of x, and that's going to equal 2 times 0 squared plus what's it, minus 5 times 0. Now actually, as it turns out, because it was a 0 value, you would have got P out anyway without knowing what A and B was. But usually sometimes it works out that way, sometimes it doesn't. So P therefore is minus 3. So look, P is minus 3. We had to find out what A and B was anyway. So A is 2 and B is minus 5. And then finally, hence calculate the value of H and K. Now, H and K is an interesting one, okay? H and K are both the values when y equals 0. When your output is 0. Okay? So look what happens here. G of x is the output, and this is 2x squared minus 5x minus 3. Okay? And it wants the output to be 0, and you got to figure out what are the two x values, h and k. Well, what you have here is a reference number. You're going to multiply minus 3 by 2 to get minus 6. Minus 6 then goes to minus 6 plus 1. So you're going to get I'm just going to, if you don't mind, I'm just going to switch it around because we always generally have the equation on the left side, not the right side, okay? So what we're going to get is 2x squared minus 6x plus 1x minus 3 equals 0. 2x bracket x minus 3 plus 1 bracket x minus 3 equals 0, and then what we get is 2x plus 1 x minus 3 equals 0, x equals 3, or x equals minus a half. Is this the answer we were sort of expecting? One of them to be on the left side of the y-axis, one of them to be on the right side of the y-axis, but the one on the right side of the y-axis is a much bigger gap. Does that match the, yep, much closer, much further away. So it's exactly what we're looking for. Okay guys, any questions about that one? Okay! Below is a graph of this function here. F of x equals x cubed minus 3x squared plus 4 in the domain minus 2 to 4. So basically, in between these 2 points is what happens. Now, just while we're here, I'm just going to explain some other things to you. X to the power 3, when your function is x cubed, it contains 2 turning points. This means that you should know that this one has to go down forever, and this one also has to go up forever. Is that right? Yeah. Now, the domain is very specific, okay? It's saying it's specified for this domain here. So when we're doing our answers, we're going to relay it back to the domain information. Okay? So, what also I'd like you to note is that it's a positive x cubed, yeah? The number in front of x cubed is positive. This means that the max occurs before the min. If it was a minus x cubed, it would look something more like this, where the min comes before the max. Just bear that in mind. You should know that information right away.
Sorry, is it minus 16, not the min first? The 2 minus 16.
Oh no, see, because that's not a turning point, Connor. Because that continues downwards, it's not actually turned. So therefore it's not considered the max or the min. Okay, it's only when it changes direction. It goes from increasing to decreasing, or decreasing to increasing. Shane? You happy enough? Yeah. Okay, now what happens next is find the values of x for which f of x equals 0. Now, f of x equals 0, what we're looking at here is when is the y value 0? Well, that's going to be minus 1 and 2. X equals minus 1, x equals 2. Find the coordinates of the local maximum and minimum points. Well, 0, 4 for the max, and for the min it's going to be 2, 0. Okay, so there's your max and min, just read directly off the graph. Okay, find the local maximum minimum ones, find the coordinates of the local maximum, local minimum points. Alright, that's grand. Now, the next question you might think is the same as question 2, but it's not. It's in reference only to the y values. Okay, local max is 4, and local min is, it's the y value, so local min is 0. Okay? Now you got to remember that, learn off. Okay? Find the value of f bracket 3.5. What usually goes in the bracket? What letter? X usually goes in here. This means you're saying x equals 3.5. You get a line, and you find where x equals 3.5. It hits around here. You make sure it goes directly up. Okay, it's and then goes directly across, and the answer is 8. Now guys, there's a way of checking that. Okay, you're going to say it's equal to 8. What I'd often do, especially in questions like this, is I'd go to the calculator, because you have such a very useful calculator these days. Okay, and I'd put in x to the power 3. I'd do minus 3x squared. Okay, and I'll do plus 4. Now, do you see the way that's... Oh, sorry, just... yeah. Okay, sorry, 3x squared, and then at the end, plus 4. Okay, Now guys, look at this, okay? The start starts at -2. The end starts at 4. Now, if I do a step of 0.5, what does that mean? I get 1.5, 2.5, 3.5, okay? So that means I'm actually, sorry, it's not 3.5. That means I can actually check out my answer quite quickly. And as it turns out, what we're looking for, 3.5?
Yeah.
Now, 3.5 is actually 10. 10.125. So this answer of A, obviously,
It's not actually 3.4 in the graph.
it's not 3.5 in the graph. So look, I can actually check that I made a mistake there. And what happened was, I didn't actually do 3.5. I did 3.3. So very easy to do stuff like this, okay, in a test. But if you have a backup option, you can actually figure out what exactly you've done. I'd say 10 now. X equals 10. Okay. So you got to be careful. Also, your calculator is brilliant. It will back up your answers. Now, find the values for which f of x is decreasing. When is it on its way down? Okay. So when is it on its way down? It starts at -4. Starts at x equals 0. Starts at x equals 0 and ends at x equals 2. All the numbers between x equals 0 and x equals 2 can be written two ways. X greater than 0, x less than 2, or we can do it as 0 less than x less than 2. They mean the same thing. Find the values for which it's increasing. Well, any value below x equals 0 is on its way up. Okay? So, but in the interest of this equation, alright, we're stopping at -2. So it's going to be -2 less than x less than 0. And then it also starts increasing at any value above 2. So -2 is less than x, and the function stops at 4.
A reminder that tomorrow, Friday, is the last day to enter the PPU photography.
So guys, what happens here is, okay, next part, right? It says, find the values of x which is less than 0. Find the values for which the function is smaller than 0. So if the function is smaller than 0, the function has to be located below the x axis. Okay? Because the y values are lower than 0. So in effect, we're basically, this question has a small range. It's only allowed in the green box. Okay? And then it says it also has to be increasing. Well, it's increasing from here to here. And that is going to be x is -2 is less than x. X has to be less than -1. If you change that to less than or equal to, what would happen then? Less than or equal to? Less than or equal to. You'd be wrong, basically. So you'd have to change to less than or equal to.
Oh, is there?
Yes?
Oh, yeah. When it says find values for which x.
So guys, in my opinion, there's two different answers for this one, right? I'd say x is less than -1 because it does go on forever, which is correct. But the reason why I'm putting the cap of -2 on is because it's specifically asking the answers for the domain -2. So I reckon in a test, I think both answers should be perfectly acceptable. Okay. So in the example, it would have capped it off at the domain as well, but I'd be aware of both answers. So I'd actually, in a test, I'd put down both answers. X less than -2, but in this question, because of the domain, -2 less than x less than 1. Okay? Alright guys, now, find the values of k for which it has 3 solutions, okay? So 3 solutions. Now, what happens with 3 solutions is that these horizontal lines, see the green horizontal lines here? These will have to, if they cross 3 times, it has 3 solutions. So at the moment it's only crossing once, starts to cross twice. We'll stop it there. Then we get this line here, and we bring it up until it starts 3 times, now it's back to twice. Any horizontal line, so for example, any horizontal line is represented by f of x equals just a number. So for example, f of x equals 20 is a straight across line that goes across at 20. F of x equals -16 is a line that goes straight across at -16. We want lines that go straight across, but yet they intersect this red line 3 times. We notice that the green line represents f of x equals 0, The second green line represents f of x equals 4. Any values in between 0 and 4 will produce a line that hits 3 times. This means that we have to find out the values of k, the range of k. K, if 0 is smaller than k and k is smaller than 4, this means any line that I draw, for example, f of x equals 3.5. The line 3.5 will cut across 3 times. 3 solutions. Okay? Now,
Joe, that's right, you're answering that form in the 0.
less than k, less than 4, yeah. You could also technically give it in words like any value between 0 and 4, but they prefer in mathematical language. Estimate the values of x for which f of x equals 2 and f of x is greater than or equal to 2. Well lads, if f of x is equal to 2, what happens? F of x equal to 2?
Line across the 2.
It's a line straight across at 2, so I'll need to just I need to get rid of these lines here. Okay. Okay, so f of x equals 2. Write a line that is, it's going to be hard for me to do because it's halfway up, okay, and I really need a less thick line. Okay, so it's around here. I'm going to get slightly wrong because of the accuracy of the graph. So I say it's going to be 1 and around 2.7. So 1 and 2.7. Okay? Because you draw the line y equals 2 and you see what x values produce the same point on the graph. F of x is greater than or equal to 2 when the function is greater than or equal to 2. Oh, there's another answer here. It's minus 0.7. So in between minus 0.7, less than or equal to x, less than or equal to 1. Do you see this point here? See this part of the graph that's above 2? That's what we're looking for there. Okay, the y value of the function is bigger than 2. And then eventually it starts again here, where it's going to be 2 is less than or equal to x, and x is less than or equal to 4. This region in here. Okay. Let's begin, okay? Each of the following functions has a domain x, m, and r. Find by completing the square the maximum or minimum point of and distinguish between them. Hence state the range of each function, okay? So, what's going to happen here is, okay, I identify this function here, g of x. G of x is now identified as a u-shaped function. Why is it u-shaped? Plus x squared. What I then do is I look at the middle value. I half that middle value and I get minus 3. I then square minus 3 and I get 9. What I'm going to change this function is into g of x equals x squared minus 6x plus 9. I'm not allowed to have plus 9 because I'm only meant to have plus 2, so I add a minus 7 to the end. I then use the what's called the reference number method for basically reference number method for factorizing this, and I'm going to get x minus 3 squared minus 7, and that's g of x. Okay. Now, to get the minimum point of this graph, what would this box have to be equal to? 0. So what value of x is a 0? X equals 3. Because this would be 3, and now we know that this is the minimum. So when x equals 3, this part goes to 0, and the y value will be what, guys? Minus 7. So this point here is the point 3 minus 7. I found the minimum point, okay? And then what I did then is, it's a minimum point, and then I'm only allowed to have values, y values above minus 7. Do you understand that? The y value will never go below minus 7. So this means that the range is any g of x is any value that's bigger than or equal to minus 7. That's the U-shaped question. Now I'm going to move on to an N-shaped question. This one here, number 5, is an N-shaped question. Okay? Now, for this question here, okay, the N-shaper, what I'm going to have to do is, I'm going to do 3. I'm going to take out a minus sign, okay? 3 minus brackets 8x plus x squared. Is everybody happy that's still the same function? Okay. Then what I do is I'm going to change it around such that the x squared is front of the ax. Like last time, I'm going to half the x value. Half it I get 4. Square that and I get 16. So what I'm going to do here is going to be 3 minus x squared plus 8x plus 16. Stop there. Well, how have I changed the function? I'm only meant to have 3, but now overall I have minus 13, don't I? Because it's 3 minus 16. How do I balance this up so that I still have 3? Well, if I took away 16, I should add on 16. 3 plus 16, 19. 19 minus, if I factorize this, what do I get? X plus 4 squared. Now I have my f of x function. Now, we know this is an n-shaped function, don't we? Yeah? Now, you're taking away a square. Squares are always positive numbers. So we want to make this square 0. So we're taking away no number, and hence we find out what the maximum is. This is 0 when x equals minus 4. X equals minus 4 is to the left of the y-axis. So when we replace in x equals minus 4, f of x is equal to 19 minus 0 squared, which is 19. This means the maximum point is 19. The point is minus 4, 19. Okay? And that means that it's, that's the maximum point. Okay? Then, once this is done, we know that the range has to be any y value below that, which is y less than or equal to 19. Okay, guys?